Notes for section A2 for your summer homework. If you understand how to do a lot of these problems, feel free to just do the homework on your own. If you need help, you can always refer back to this. I'll do a couple of examples here with you to try to help you out. I'm going to start by evaluating the following without a calculator. You'll see next year in Honors Functions and Trig we do a lot of simplifying radicals without calculators, so it's a good skill to have. So letter A, 36 to the 3 halves power. Remember that you can rewrite this as 36. Whatever the denominator is, that is the root of the problem. So you could say it's the square root, and then the exponent number is the power. So it could be rewritten as the square root of 36 cubed. Or if you really wanted to, you could say it was 36 cubed and then the square root of it. Either one of those are fine. They both mean the same thing. So I'm going to do this part of it. I'm going to do the square root of 36, which I know is 6, and then I'm going to cube that, and that will end up giving me 216. Now it ends up working here the same. You're eventually going to get 216, just whichever way you think is easier. Generally, I like to do the root first and then do the power, but it's up to you. Alright, so for letter B, I have a cube root of a negative number. Now you probably are used to seeing a negative inside and saying that there's no solution. That's true if this is an even root. If it's an odd root, it's okay for this to be negative, because if you think about multiplying 3 negative numbers together, it would eventually give you a negative number. So I know the answer is not going to be no solutions. It's just going to be negative something. So if you remember working with a fraction, you can separate and do the numerator and the denominator separately. Now where I put the negative is kind of up to me. I can put it either on the 27 or the 8, or I know eventually the answer is going to be negative, so I'm just going to go ahead and move the negative out front. And now I'm going to do the cube root of 27, which, think of what number multiplied times itself 3 times gives you 27. It's 3. And then what number multiplied times itself 3 times gives you 8? It's 2. And so that one would be negative 3 halves. So if I move down here to letter C, here's another negative radical, and this time I do have an even root, so this one actually is no solutions. Or sometimes a book might say undefined. Either one of those answers would be acceptable. Alright, moving on to the next one. I've got another fractional exponent, kind of like I did for letter A. This time it's negative. And when you have a fraction to a power, remember that both of these numbers are to that power, so this is the way that it would be written. It's kind of like distributing. I would say it's 1 to the negative 1/3 power divided by 64 to the negative 1/3 power. And then if you remember, we usually when we're simplifying, we didn't want negative exponents, so to quote-unquote fix it, you took the term with the negative power, and if it was in the numerator, you moved it to the denominator, or if it was in the denominator, you moved it to the numerator. So it essentially flips. If you have a fraction to a negative power, it essentially just flips it over, and it would become 64 over 1, which of course is just 64, to the positive 1/3 power. And now when you have a fractional exponent, remember you can rewrite it using radicals. This is really the cube root of 64 to the 1st power. I don't necessarily need to say that. And now just think to yourself, what times what times what is going to give you 64? It would eventually be 4. Alright, moving on to letter E, starting to get something a little bit more complicated. I have the 4th root of 64x to the 7th. Now, for a lot of the radicals, you can just see, like if I look back here at letter B, I can just look at 27 and 8, and I know that 3 times 3 times 3 is 27. It starts to get a little tougher when you start to get 4th, 5th, 6th powers for roots. So what I suggest doing, and you don't have to do it this way, but it's a good idea, is just take 64, and we'll take x to the 7th in a second, and we're just going to break this down into prime numbers. So I know two numbers that I can multiply together to get 64 are 4 and 16. Or you can say 2 and 32. Or you can use whatever numbers you want to. Eventually you're going to get the same prime numbers. 4 could be broken down to 2 and 2. Those are prime, because the only way you can get them is to multiply the number times 1. 16 could be 4 times 4. And each of these 4s will give you 2 2s. So essentially what you have are 1, 2, 3, 4, 5, 6 2's getting multiplied together. Of course, x to the 7th means you have 7 x's multiplied together, so I don't know that you would do this, but this is essentially what you're looking at. It's the 4th root of 2 times 2 times 2 times 2 times 2 times 2, 6 of those, and then 1, 2, 3, 4, 5, 6, 7 x's. The reason I like doing it this way is what this root number is saying is that once you have 4 of the same thing, so for example, right there, that number is now allowed to come outside of the radical. Because if you multiply all those together, it gives you the 4th root of 16, which happens to be 2. These, because there's not 4 of them, they have to stay inside the radical. Then come over here and do the same thing. I have 1, 2, 3, 4 x's, so that x would get to come outside the radical. I'll squeeze that in right here. And then those 3, because it's not a group of 4, they would have to stay inside the radical. So your final simplified answer would be 2x times the 4th root of 4x cubed. And now I've simplified that radical. Letter F, the last one of these, before we do some other examples. Now we're asked to add 2 of them together. So it's the same thing, just simplify this one on its own, simplify this one on its own, and when you're done you can add like terms if you have them. So they're both square roots, so I'm going to try to break down 48. So leave the negative 3 alone. I've got the square root of 48 could be rewritten a couple different ways. I could say it's 2 times 24. I could say it's 4 times 12. Or 16 times 3 might not be a bad way because I know the square root is 16. Again, you can use this strategy and just count the number of 2's or whatever it is you have. X squared, that's just 2 x's. You don't have to show that to me. If you know that that's going to turn into an x, that's fine. I know the square root of 16 is 4, so keep the negative 3 in front. Square root of 16 is 4. There's a grouping of 2, so x can come outside. That random 3 has got to stay inside. So this one term will simplify into negative 12x square roots of 3. However many things you bring outside of the radical, you end up multiplying those together. Whatever is left inside the radical, you multiply those together as well. Same strategy over here. I have 7 square root of, if I changed 75 into 25, a perfect square, times 3 times x squared. I know the square root of 25 is 5, so this would be 7 times 5. Square root of x squared would be x, and then that 3 again would have to stay inside. So this will give me 7 times 5, or 35x square roots of 3. And now these things will be considered like terms if the radicals are exactly the same. That means the root number has to be the same and the number inside has to be the same. And if they have a variable on them, the variables have to be the same as well, and their exponents. So these are both x square roots of 3, so I've got negative 12 of them over here. I've got 35 of them over here. If I go ahead and add those together quick, it looks like I have a total of 23 x square roots of 3, and that would be my final answer. So there's doing some simplifying without a calculator. Got a few extras for you. You also do a lot of rationalizing. You're going to see a lot of the problems that we work with next year, and a lot of the answers that you get tend to have radicals in them. And hopefully you know, and as well as you should, that you can have a radical on the bottom. It's not that you can, it's just it's not considered simplified, and we are always supposed to simplify our answer. And so the easy way to do this is you rationalize. In other words, you multiply by square root of 7 over square root of 7. It's a fancy way of multiplying by 1, so I'm not really changing anything. Multiply the numerator together, it gives you 3 square roots of 7, and square root of 7 square root of 7 is 7. And now there is your answer rationalized. For letter B, same concept. The problem is you've got a quantity down here. So I can't just multiply by square root of 3 over square root of 3, because when I distribute the square root of 3, I would have 2 square roots of 3 minus 3, and that doesn't fix the problem. That still leaves me with a radical on the bottom. So what you need to do is multiply by the conjugate of the denominator. And I'm sure you've heard this before and seen this done. You're going to say the conjugate is what happens when you switch the sign here. It would be 2 plus the square root of 3. And of course you have to do that to both the numerator and denominator because you have to multiply by the same thing. This is just a fancy way of writing 1, so I know I'm not actually changing anything. Now in the numerator, if I distribute this 4, I'm going to get 8 plus 4 square roots of 3. In the denominator, the reason that we choose to multiply by the conjugate is because the insides and outsides will cancel. So when I multiply the first together, when I do my foiling, I get 4 Negative 2 square roots of 3, positive 2 square roots of 3, they're going to cancel. And then just make sure you pay attention to the sign. This is going to give you negative 3. Of course, the denominator is just 1 for this one, so we're pretty much done. It's 8 plus 4 square roots of 3. And now I'm simplified. It doesn't have to work out that the denominator is 1. You just have to have something that doesn't have a radical in it. If the denominator was left with a 2, then you should break the numerator apart and divide both of these numbers by 2 and simplify. Alright, letter C and D. A little bit, again, more challenging because of the fact you've got numbers and variables inside. So I have the square root of 32x to the 5th divided by b to the 7th. So I know 32 could be rewritten as 16 times 2, and there's a perfect square. X to the 5th could be rewritten as x squared, there's a perfect square. X squared, there's a perfect square, and then that random x that's left over. Divided by b to the 7th could be rewritten as b squared, which is a perfect square. Another b squared, another b squared, there's 3 perfect squares, and then there's one random b left over. So the 16, these two x squareds, and all 3 of these b squareds, they're all allowed to come out front. Now remember, the square root of 16 is 4. The square root of x squared would be x. Square root of x squared would be x again. There's still this 2 and that x left inside the radical. On the bottom, the square root of b squared would be b, b, and b, or b cubed. And then the square root of b is still left in the bottom. Alright, so I did the simplifying in terms of getting rid of or taking out whatever I could. I still haven't rationalized because there's still a radical on the bottom. Same concept that you did up here. Whatever was in the denominator, just multiply both numerator and denominator by it. So because it's b, I'm going to multiply by the square root of b over the square root of b. And that will give me in the numerator 4x squared from this. I have 2x and b, nothing that comes in a pair of 2, so they all have to stay in there, and order doesn't really matter how you write it, but 2xb divided by these 2 square roots of b now become a regular b outside the radical, and you have a total of 4 of them. So it would be not x, but b to the 4th. And now you have rationalized it. Same concept for letter D, but the fact that this is cubic makes it a little bit more tricky. So that means I need groups of 3 that can come out. Now the first thing I would do is when I'm given a problem like this, I didn't do it over here because I knew it wasn't going to happen, but this could be simplified. 4 and 6 have 2 in common. X squared, x to the 3rd, that can be simplified. I would do that immediately before I start trying to simplify or rationalize or do anything else. So I'm going to divide the 4 and the 6 to say that this is 2 over 3. The x is simplified, so there's just one x on the bottom and just one y on top. And so I have it already broken down into prime terms like I did here. So nothing can actually get pulled outside of the radical. I don't have a perfect cube in there. But here's the trick. When I go to rationalize this, I can't just multiply by the square root of 3x. And the reason I can't do it is, one, it's not a square root, so if I do this and say, okay, well, now it's a cube root, well, think about it. I have to have 3 3's before I can take it outside, so I only have 1 3. So instead of just multiplying by 1 3, I need to multiply by 2 3's. And instead of multiplying by just 1x, I need to multiply by 2 x's. So I'm actually multiplying by 3 times x, or 9x squared. And now when I do that, if I look at the numerator, I have 1 2, 1 y, 2 3's, 2 x's. I don't have a group of 3. So this is just going to be the cube root of, multiply the numbers together, so 18, and then x squared y. In the denominator, I now have 3 3's, so 3 can come outside the radical. I now have 3 x's, x can come outside the radical, and I have nothing left inside the radical, so I don't need the radical anymore. And there it is. If this was a 4, I would need 3 3's. If there was 2 3's in here, then I would only need 1 3 in here. So it kind of just depends on the problem that you're dealing with. But like I said, a little bit more tricky because of the fact that it's cubed. The last type of problem that you see in this homework is simplifying something like this, where you have negative exponents, positive exponents, some things in parentheses, some things not, and so there's a little bit of understanding you have to do. This one, I think, is simple enough. It's a negative exponent. To simplify, if you want, you can move it to the denominator. That's one option you have. This term here, it's in parentheses, so remember that it's kind of like distributing. Since these are being multiplied, I would put the 3 halves power on both the 5 and the x. There's no parenthesis around here, so 5 has its own little exponent of 1. And that's the thing you have to be careful with, because most people will assume that the 5 and the x go together, but not quite. So this is going to be written really as 5 to the negative 1 half times 5 to the first times x to the 5 halves, divided by, and now I'm going to put the 3 halves power on both of those. That would be 5 to the 3 halves times x to the 3 halves. Now, important that these are being multiplied together. If they're not, if this was, say, 5 plus x to the 3 halves, then you can't really do anything with it. You would have to just leave it. You shouldn't have anything like that in your homework, though, today. All right, so now simplifying. If you want to bring this down to the denominator, you can, or you probably remember your rules of exponents. You can add the exponents here. Kind of up to you. But I'm going to combine like terms, so I'm going to try to group those together. Since I have x to the 5 halves on top, x to the 3 halves on bottom, my rule would be to subtract 5 halves minus 3 halves, which would give me 2 halves, or 1. So I'm going to eventually have 1x on top, or an x to the first on top. If I combine these together, starting with the numerator, this would give me 5 to the positive 1 half if I add those together. Still have that 5 to the 3 halves in the denominator. And now if I subtract, I'm going to end up with 5 to the negative 2 halves, or to the negative first, times x. And like I said, we don't usually leave something with a negative exponent. To simplify it completely, it would be x over 5 to the first. The to the first powers are implied to be there. You don't actually need them. Hopefully this will help you out for the homework for section A2.